So number 33 is going to be your motion, right? Your projectile motion question. So you're going to have one. I put a rabbit on here because it's Easter, just was Easter. So we've got a little rabbit jumping across the floor, and so we'll draw our floor, and he jumps at an angle of 60 degrees, and his initial velocity, or speed they call it, is 3 meters per second. So G is going to be 9.8, right? Meters per second squared. Gravity, well, we won't even use units for gravity, don't worry about it. Gravity, and H naught is equal to 0. So let's see what it says. Now here's another thing that in the homework it didn't ask this way, but that's what it's asking for. It says write a set of parametric equations for the motion of the rabbit. So basically it wants an x equals for the horizontal distance and a y equals for the vertical distance. So that's what part I is asking for. So x, remember, is t v naught times cosine of theta. So if we're going to write it, we're going to put the numbers in. We don't know t, that doesn't matter, and then it's 3 and cosine of 60 degrees. Well, we know cosine of 60 degrees is a half, right? So this would be 3/2 t. So we have a formula for our horizontal distance. The other parametric equation would be t v naught sine theta minus 1/2 gt squared plus h naught. So let's fill that in. Y equals t times 3 times sine of 60 degrees minus 4.9 t squared. H is 0. So let's simplify this out. Y equals sine of 60 is square root of 3 over 2. So 3 square root of 3 over 2 t minus 4.9 t squared. So there's part I. We've got two equations solved for x and y. This is the horizontal and this is the vertical. We've been doing these. So number double I, determine how long the rabbit was in the air. So we want to know this time. And what's true about this time? The height is 0. So we have to put 0 for y. 0 equals 3 square root of 3 over 2t minus 4.9 t squared. So then we have 4.9 t squared equals 3 square root of 3, let's factor, minus 3 square root of 3 over 2t equals 0. So factor out a t and you get 4.9 t minus 3 square root of 3 over 2 equals 0. So t equals 0, which of course is the time he started, right, down there. And then the next one would be 49t equals 3 square root of 3 over 2, or not 49, 4.9. So t is 3 square root of 3 over 2 over 4.9. So if you use your calculator for that, you should get 0.53 seconds. This is meters per second, so 0.53 seconds. That's how long the rabbit traveled in the air. So, all right, what does 3 ask us? 3 says, determine how far the rabbit traveled in the air. So how far, that would be our x, right? So triple I would be x equals, and now our time was 0.53. So let's write the formula. It's t v naught cosine theta. Then we already know that the cosine is 1/2. So what did we get for x? I forgot. Let's go back and look. We got 3/2 t. That was pretty easy. So let's go forward. X equals 3/2 times t, which is 0.53. So if you multiply that out, you get 0.80 meters. So that's how far he didn't quite jump a meter when he was in the air. All right, so let's go on to 4. Determine when the rabbit reached its maximum height. So this is the time. Okay. So when did he reach his maximum height? Well, you know what? We had this picture, and it took him the whole time. This was 0.53 seconds to get from here to here. And so he was at its maximum height halfway through there, right? So let's just use logic. So let's say 0.53 divided by 2, which is equal to 0.27 seconds. So that's when the rabbit reached the maximum height. So that's time. And then 5, determine the maximum height reached by the rabbit. So that's our y equation with this time set in it, right? So we have y. What was our shortcut y? Let's look over here. We had 3 squared, 3 over 2t minus 4.9t squared. So y equals 3 square root of 3 over 2t minus 4.9t squared. So now t is 0.27, so 3 square root of 3 over 2 times 0.27 minus 4.9 times 0.27 squared should come out to be 0.34 meters. So he went as high as 0.34 meters. And let's double check we've done everything right. We wrote the equations. How long was the rabbit in the air? That was time. We did time. How far was it? That's x. When was it at some maximum height? That was the time halfway through. And then determine the maximum height. That was y. So that's how you do that one. There will be one like that on there. Very similar. Very similar. So this was the review session. I am going to give you, I hope you took good notes. I'm going to give you another set of these questions just like these, so you can work them out on your own and then check your answers to study. Okay, I would recommend that. And then the test will be on Friday, and it'll be extremely similar to these questions. The numbers won't be the same, but there's going to be no surprises. Okay, so study hard.